approximation and probability understanding. Let's read some more questions, and then we'll be able to analyze. Now, let's look at another question. A box of chalk contains 5 white, 4 green, 2 red, and 1 yellow chalk. In how many different ways can they be arranged side by side? Calculate the probability that the green chalk are side by side. We have 2 questions here. The first one is asking us, how can this chalk be arranged side by side? And we have 5 white plus 4 green plus 2 red plus 1 yellow. So how many chalks do we have in this instance? 12 chalks. But look at it. We have 5 which are similar, 4 which are similar, 2 which are similar, and 1 here below. And from our understanding of arrangements, we ask how many different ways can they be arranged side by side. These are similar. You understand? Because we have similar chalks here. You can now say that the total number of arrangements will be equal to 12 factorial divided by 5 factorial times 4 factorial times 2 factorial. That is the total possible arrangement because we have similar chalks by color there. Now the second part says that you calculate the probability that the green chalks are side by side. That is, they are all together. Now if you look at it, without the green chalk, how can we arrange the other 8? So the other 8 chalks can be arranged in 8 factorial over 5 factorial times 2 factorial and probably 1 factorial ways. Now, because we have these 8 chalks here, it has given the 4 green chalks 9 positions it can stay. You know, we have 1, 2, 3, 4, 5, 6, 7, 8. So these green chalks can be here, 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 and can be here. You understand? So we have 9 different positions because they are together as one. So we have 9 positions for the green chalks to stay now. So the total arrangement with the green chalk now will be equal to 9 times 8 factorial over 5 factorial times 2 factorial times 1 factorial. Take note, please. The green chalk, they are together now. So it will be like 1. It will be like 1. You understand? Unless you want to make it times 4 factorial here, that is, they can change, and then we divide by 4 factorial again. And to me, which is not necessary to prevent confusion. So we don't have this here. So this is what we have. Now, the probability as asked that the green chalks are side by side. Green chalks are side by side will be equal to this one over that one. That is 9 times 8 factorial over 5 factorial times 2 factorial multiplied by 5 factorial times 4 factorial. So we can now say that the probability with all the green chalks are side by side is equal to this one divided by that one. So if you look at this one is giving us 9 factorial over 5 factorial times 2 factorial. So that will give us 9 factorial over 5 factorial times 2 factorial multiplied by 5 factorial, 4 factorial, 2 factorial over 12 factorial. So look at it. This one over this one, I've cancelled this side. So I have 9 factorial multiplied by 4 factorial divided by 12 factorial. So 9 factorial from here gives us 12 times 10 times 11, so 24. So that's the answer, 1 over 55. That's the probability of all the green chalks being together. Let's look at this one. In how many different ways can the letters of the word calculus be arranged? So we have it like this. Calculus. And how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 letters. Now, we have similar letters as well. Let's look at it. See, we have 2. A, we have 1. L, we have 2. U, we have 2. S, we have 1. So we can see that is 8. So which means that the total number of arrangements, total number of possible arrangements will be equal to 8 factorial divided by 2 factorial multiplied by 2 factorial multiplied by 2 factorial. We don't need to add 1 again. Just like that. We are now ask another one. How many different arrangements begin and end with the same letter? Because we have this just as 2, 2, 2, we have to consider each separately. Now, assuming we have this starts with C and C. So we have C and C. And they are similar. You understand? So you can say, okay, we have 1 here, we have 2 for this place. So 1, 2, 3, 4, 5, 6, 7. So the other 6 letters can be arranged here in how many ways? Let's calculate. That is going to be 6 factorial divided by, you know, we have removed the 2 C's now. So we have 2 factorial times 2 factorial and 1. 1, 1. So we have 6 factorial here now. So with this now, you know, we can interchange these 2 now. This C. So we have times 2 factorial over 2 factorial because they are also similar. So at the end of the day, our number of arrangements when C and C start and end the letter is going to be, for C and C, is going to be 6 factorial over 2 factorial times 2 factorial. Now let's now change the letter. Let's change it to LL. LL. We are going to have the same number of arrangements because everything within is still like, we are going to have 2, 2, and then we are having 1, 1, 1. So we are going to have another one for LL. So for CC, we have 6 factorial over 2 factorial, 2 factorial. For LL, we are going to have 6 factorial over 2 factorial, 2 factorial. And then we have another one, UU. It's going to be 6 factorial over 2 factorial, 2 factorial. So total, when same letter begins and ends, it's going to be 3 times 6 factorial over 2 factorial times 2 factorial. So that is our answer. You can easily do that with calculator. Now here, a group of 6 men is chosen from 10 men. Find probability that a certain 2 men are included in the group. Now, what is the total possible of selection of 6 from 10? So total possible ways of selecting 6 men from 10 men is equal to 10 C6. Now, if we have already chosen 2 men, that is, we have 2 men already, and now we are going to select 4 again from the remaining 8 to make it up, because we are saying that what is the probability that these 2 men are already there. So we have 2 men already. Now, the real selection we are going to make now is 8C4 to make it up. That is selection of 4 men from remaining 8 men. Since we have already had these 2 people. So the probability now of having 2 certain 2 men will be equal to 8 C4, 8 selecting 4 or choosing 4 divided by 10 selecting choosing 6. And let's see if I can simplify it. It's going to be 8 factorial over 4 factorial 4 factorial times 10 factorial over 10 minus 6 factorial 6 factorial 4 factorial. Cancel. So once again, here, this one is going to give me, by the time I do 6 times 5, and this one is going to give me 10 times 9. 3. So 1 over 3. So that's the probability of having 2 certain men already in the group. Now, every Saturday, a man invites his sister to the cinema or theater. 70% of his invitations are to the theater, and 90% of these are accepted. His sister rejects 40% of his invitation to the cinema. Find the probability that the brother's invitation is accepted on any particular Saturday. So from this, we know that there are 2 places the brother invites the sister: cinema or theater. So which means that, let's look at it: cinema, theater. So 70% of his invitations are to the theater. So we have it like this: 70% comes in, which means that 30% is for this place. And you are now told that, okay, 70% of his invitations are to the theater, and 90% of these are accepted. So we also told that out of this, 90% is accepted. At the same time, it means that 10% is rejected. And 40%, his sister rejects 40% of his invitation to the cinema. So we have 40% here is rejected. So it means that 60% is accepted. We are now asked to find the probability that the brother invitation is accepted on any particular Saturday. Now, for us to have a clearer view of this, I'd rather we use tree diagram. Let's see how it will look like. So from here, we have theater, cinema. And we know that this one is 30%, and this one is 70%. Now for the cinema, we know something, that 60% is what? Accepted. 40% is rejected. And for this one too, 90% is accepted, and 10% is rejected. So from here, we can really determine the proportion of total accepted and total rejected. 70%, 30%. So from here, we know that 10% from the theater is what's it called? Rejected. So we can say that 70% times 10% rejected from theater. Okay, you are looking for accept. So from this diagram now, we can easily know which proportion of the total invitation is accepted. So we know that 90% of the theater is accepted, and from the total invitation, once to theater is 70%. So from here, the total accepted from theater is equal to 90%. And from the total invitation is equal to 90 times 70%. So we know this one to be 63%. Now from the cinema, what is the total accepted? We know that it's going to be 60% of the invitation to the cinema. And the invitation to the cinema is 30% of the total invitation. So acceptance from here is going to be 60% of 30%. 60% of 30%. And that's going to be 18%. So, go. And that's going to be 18%. So total accepted accepted invitation. Total possible accepted invitation will be equal to 63 plus 18 percent, and which is equal to 81% or 0.81. Simple. So that is the solution to that. A boy walks to school 60% of the time and cycles 40% of the time. He's late to school on 5% of the occasion that he walks, and he's late on 2% of the occasion he cycles. A boy walks to school 60% of the time and cycles 40% of the time. He's late to school on 5% of the occasion that he walks, and he's late on 2% of the occasion that he cycles. Given that he's late to school, find the probability that he cycles. That is P late, 1 he cycles. Let's analyze the information. So, the boy walks, and this one he cycles. Here, we are told that it is 60% of the time, and this one is 40%. Out of this, he's late when he walks. This is late, 5%. And punctual, 95%. But when he cycles, he's late, 2%. And he's punctual, 98%. Now, we are now asked to find the probability that on the day he was late, but what is the probability that he cycles? What is the probability that he cycles? Now, which means that we are going to find the total possibility of being late, and then we will now find the possibility of when he cycles that is late. We now use it to find probability. Let's go on. Now, this is the total time allotted to cycle and walking. So let's put this one as walk and this one as cycle. And this one is 60%. And this one is 40%. Out of this time now, he is late by 2%. And punctual. Oh, he's late by 5%. So this is it. And he's punctual by 95%. And this place, he cycles. He's late by 2%. And he's punctual by 98%. This is 98%. Now, let us calculate the total possibility of his being late. The total chance. Let's see. For this one to be late, we are going to have 60% of the time, and out of the 60% of the time, he's late by 5% of the time. Here, he cycles by 40% of the time, and then he's late by 2% of the time. So the total time of his being late, let us see. Here is 3. So this one is 3 over 100. That is total time he's being late when he walks. The percentage of the total time when he walks that is late. Now for this one, I have 8 over 1000. So which is that out of the total time that he attended the school, he was late by 8 over 1000 of the time due to his cycling. This one, he was late by 3 over 100 due to his trekking or walking. So total time of lateness is equal to 3 over 1000 plus 8 over 1000, which is equal to 38 over 1000 of the time. For the total time he attended the school. So that is the total time he is late, either due to walking or cycling. But we are now asked to find the probability that this time that is late, what is the probability that he cycled? And that is going to be gotten by saying the total time of being late by cycling over all the overall total time that was being late by cycling and trekking. And we get that one by, let's do that. So here, please take note. Lateness due to trekking or walking. Sorry, let me do that. Here, lateness due to cycling. So total lateness, that is it. Now, probability of lateness due to cycling is equal to 8 over 1000 divided by 38 over 1000, which is equal to 8 divided by 38 4 over 90. So that's the probability that is due to, that is, it was late. But out of that lateness, how are we sure that it was due to cycling? That is what it means. It's not that we are calculating the lateness due to cycling of the overall time. We are taking that out of the total lateness. What is the probability that the lateness happened when it cycled? That is what this PCL means. 3 balls are drawn at random simultaneously from a bar containing 3 red balls, 5 black balls, and 4 yellow. What are the probabilities that the 3 balls are A, all yellow, B, one of each color? Here, we have how many balls? 3 plus 5 plus 4, which is 12 balls. And we are told that 3 are drawn at random. So, what is the total possibility, total 4 ways of selecting 3 balls out of this? So, total possible selection is going to be 12. Now, we are asked, what is the probability that the 3 balls are all yellow? So the total possible selection of all being yellow, because we are going to be able to do that from 4 yellow balls, it's going to be 4C3. Therefore, the probability of all being yellow is equal to 4C3 divided by 12C3. And this is 4 factorial over 3 factorial times 12 factorial over 9 factorial 3 factorial. So this one cancels this. So we are going to have 4 factorial divided by 12 times 11 times 10. I know 4 factorial is 24. So this one, guys, 5. Now let's go to B. It says one of each color. So B. So which means that we are going to select one from red, one from black, and one from yellow. So we are going to have total selection of one from each color is equal to 3C1 times 5 choosing 1 times 4 choosing 1. So we know that this is going to be just 3 times 5 times 4. That is 6. And then the total probability. The probability of choosing one from each color is equal to 60 divided by 12 selecting 3. And that is giving the 12 times 11 times 10. And that is 12 times 11 times 10 divided by 3 factorial. And that is 2 times 11 times 10. That's 2 times 3, 11. So it's going to be 3 over 11. So you can just work it out. If this divided by 12, 60 be divided among 3 persons, A, B, and C, so that A and B receive 2 coins each, and C receives the other in 210 weights. If instead, no 2 of the persons receive the same number of coins, but each receive at least 1 coin, and none is left over, in how many ways may the division be made? Now, in this first one, they specify that A, B will collect 2 each. They were specified to collect it. Now, let's see how it will be. Just like when we are saying, okay, this one collects 1, this one collects 2. So, if out of the 7, we have 7 coins, I want to divide it among them. If A collects 2, the remaining for B will be 5, and the remaining for C will be 3. So, A has the option or opportunity of making 7 combination 2. That's the choice for A. For B, 5. B can be the first to select also. C can be the first to select. And C, 3. So you can see. You can start even with C. You can say 7 C3, 5 C2. So now, this is 1 times, what is 5 C2? 5 times 4 over 2 factorial. And that is 10. What is 7 combination 2? That is 7 times 6. That is 42 divided by 2. That is 21. So the answer is 210 weights. So we have done that of the first part. Very easy and straightforward. So we now ask, if instead no 2 persons receive the same number of coins, but each receives at least 1 coin. Let's see how that one goes. And we were told that at least they must collect at least 1. So let's see how it will be. Let's say we give the first person, in this instance, we are not going to put face. The first person, let's say we give him 1. The second one, we give him 2. The third person, we give him 3. So it won't work. Let's see. The first person, we give him 2. The second person, we give him 3. No, it won't work like that. For them to be, not to have equal, let's make it like this. 1, 2, and 4. That's the easiest way. That's the way it can be. Because if we make it 3, 3 or whatever, which means 2 people are going to collect equal ones. But now, none of them must have equal. And let's see how the choice is going to be like. We can start with this, or we can start with this. Let's start with this. So, the number of ways of selecting 1, 2, and 4 or unequal. The number of ways of selecting 1, 2, 4 or unequal coins is going to be 7C1 times 6C2 times 4C4. You can start with saying 7C4, 3C2, 1C1, and you get your answer. The best. Or you can even start here 7C2, 5C4, anyhow, but you get your answer. So for them not to have equal now, we are going to have it to be 7. What is 6 combination 2? And that's going to be 6 times 5 over 3. I think that should be 15. 6 times 5 over 2, sorry. And 4 times 4, that's 1. So what is 7 times 15? 105. But mind you, we did not put face to this one, to this one, to this one. So this one can go to either of them. This one can go to either of them. This one can go to either of them. So the number of ways of having this is going to be number of ways of having 1, 2, 4 points. Among them will be equal to 3, 3, which is equal to 3 factorial 6. So total number of ways. Total number of ways of dividing 7 coins unequally. Among them will be equal to 6 times 105, which is 6. mathematics department has 10 professors and will offer 20 different courses next semester. Each professor will be assigned to teach exactly 2 of the courses, and each course will have exactly 1 professor assigned to teach. If any professor can be assigned to teach any course, how many different complete assignments of the 10 professors to the 20 courses are possible? Now we have 10 professors and we have 20 different courses, and each professor is going to teach 2 subjects each, or 2 courses each. Now, the way to do that, to assign it to the professors, is like we have total of 20 courses and 10 professors. Each teach 2 courses. So the way to select for the 10 professors is going to be 20 C2 times 18 C2 times 16 C2 times 14 C2 times 12 C2 times 10 C2, 1, 2, 3, 4, 5, 6, times 8 C2 times 6 C2 times 4 C2 times 2 C2. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And after this, either of these can go to any of the professors. Either of these can go to any of the professors because it's not put to one professor. Either of them can take any course. So we are going to have number of ways of distributing is equal to 10 10, which is 10 factorial. So for this one now, this one, number of ways of choosing 2 courses for each professor. So this is it. It's going to be 20 factorial over 18 factorial times 2 factorial times 18 factorial over 16 factorial times 16 factorial over 14 factorial 2 factorial times 14 factorial 12 factorial 2 factorial times 12 factorial 10 factorial 2 factorial times 10 factorial 8 factorial 2 factorial times 8 factorial 6 factorial 2 factorial times 6 factorial 4 factorial 2 factorial times 4 factorial 2 factorial 2 factorial times 2 factorial 2 factorial 0 factorial. So we have it like this. Now, considering this, we can have this cut, 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 and you see. So you can now leave it like this. You can see that 20 factorial remains up, but 2 factorial. How many do we have below? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 2 factorial raised to power 10. That is the number of ways of choosing 2 courses for each professor. But the number of ways of assigning it to them will be this one multiplied by this. Because it is not specific to any professor. So now we have to now say, okay, this one can still go to this one can still go to this. So we are going to multiply this by this. Therefore, total number of assignments of the 10 professors, 20 courses, is equal to 20 factorial, 10 factorial over 2